We are in section 8.4, Applications of Radian Measure. First, we will define a radian, and for this we need a central angle. This is an angle whose vertex is at the center of a circle. In the image to the left, we are given a circle, and the radius of this circle is r. If we draw an arc that has the same length as the radius of this circle, then the measure of the angle formed has 1 radian. Let's call this angle theta, and theta equals 1 radian. So again, if the length of this arc is the same as the radius, then the angle formed here has the measure of 1 radian. 1 radian is approximately 57.3 degrees. Now let's consider another circle. This circle has the radius r, and the length of the arc is twice the radius. Then the measure of angle theta will be 2 radians. We can also find the measure of angle theta by dividing the length of the arc by the radius. In this case, the length of the arc is 2r, because r plus another r makes 2r. Then if we divide 2r by the radius r and r will cancel, and we will get 2 radians. Now let's consider one more circle. In this circle we have an arc whose length is 3 times the radius. Then we can say that the measure of angle theta is 3 radians. We can also say that theta can be found by dividing the length of the arc, which is 3r, by the radius r. R and r will cancel, and theta will be equal to 3 radians. In general, given the length of the arc s and the radius r, the measure of angle theta can be found by dividing s by r, and the measure of this angle will be in radians. So theta equals the length of an arc divided by the radius, or theta equals s over r radians. Now let's rewrite this formula, theta equals s divided by r, and let's multiply both sides by r. So we will multiply the left side by r and the right side by r. On the right side, r and r will cancel. Then we can say that s equals r multiplied by theta. So to find the length of an arc, we have to multiply the radius by angle theta, and this angle has to be in radians. And one more time, angle theta has to be in radians and not in degrees. Now let's try an exercise. This is exercise 7 on page 257. We are given the length of an arc of 915 millimeters. Angle theta is 136 degrees, and we have to find the radius of the circle. The previous formula was telling us that we can find the length of an arc s by multiplying the radius and the angle theta. We can solve this formula for r by dividing both sides by theta. Then r equals s divided by theta. This is the formula we will use to find the radius. And we have to keep in mind that theta has to be in radians. Therefore, in the first step, we will convert 136 degrees to radians. So theta equals 136 degrees, and to convert it to radians, we will multiply it by pi radians over 180 degrees. The symbols for degrees will cancel, and if we multiply 136 by pi, then we divide by 180, we will get approximately 2.374 radians. Now we will use the formula to the right to find the radius. R equals s divided by theta, and we will replace s with 915 and theta with 2.374, and the radius will be approximately 385 millimeters. In this lesson, we will also talk about the area of a sector of a circle. In the image to the right, we are given a circle, and the radius of this circle is r, and a sector of this circle is shaded in pink. Then the area of this sector can be found using the formula A equals 1/2 theta multiplied by the radius squared, and theta has to be in radians. Let's apply this formula in exercise 11 on page 257. Here we are given that the radius of a circle is 3.8 centimeters, theta is 6.7 radians, and we have to find the area of the sector. To find this area, we will replace theta with 6.7 and r with 3.8. Then A equals 1/2 times 6.7 times 3.8 squared. With the help of a calculator, we will get that the area is approximately 48 square centimeters. Now, let's review one more time the relation between the measure of a central angle theta in radians, the length of an arc, and the radius of a circle. To find the measure of an angle theta in radians, we use the following formula. Theta equals s divided by r. S represents the length of an arc, and r represents the radius. To find the length of an arc, we use this formula. S equals theta multiplied by r. And to find the radius, we use this formula. R equals s divided by theta. And again, keep in mind that in all three formulas, theta has to be an angle in radians. Now, let's talk about linear velocity. The linear velocity of an object moving along a circle is v equals s divided by t. So here we have a circle, and on this circle we have an object, and this object is moving along the circle. This object travels a distance s along the circle. If we are given the time that this object needs to travel this distance s, then we can find the linear velocity by dividing the distance by the time. In the example to the right, an object travels 20 inches in 5 minutes. Let's illustrate this problem using a circle. So here we have an object, and this object travels 20 inches along this circle. We find the linear velocity by dividing 20 inches by 5 minutes. The linear velocity is 4 inches per minute. This means that every minute the object travels 4 inches. Next, we will talk about angular velocity. The angular velocity of an object moving along a circle is omega equals theta divided by t, and theta has to be an angle in radians. In the circle below, we have an object that is moving along the circle. This object travels a certain distance, and the central angle formed is angle theta. If we divide this angle theta by the time needed by this object to travel, we will get the angular velocity. The example to the right tells us that an object travels pi radians in 2 seconds. We will find the angular velocity. We know that pi radians converted to degrees is 180 degrees. If we divide this angle of pi radians by 2 seconds, we will get the angular velocity. Pi divided by 2 is pi over 2 radians per second. We can say that this object travels pi over 2 radians every second. And pi over 2 radians is the same as 90 degrees. So the object travels pi over 2 radians in the first second and another pi over 2 radians in the second second. So if the linear velocity tells us the distance traveled by an object along the circle per a certain unit of time, then the angular velocity tells us about the angle traveled per a certain unit of time. Now, let's talk about the relation between linear and angular velocity. For this, we will use the following formulas. The length of an arc S equals theta multiplied by r. The linear velocity v equals s divided by t, and the angular velocity omega equals theta divided by t. We will start by using the formula for the length of an arc, s equals theta multiplied by r. Let's divide both sides of this formula by t. Then on the left side, s over t represents the linear velocity, and it will be replaced with v. And on the right side, theta over t represents the angular velocity, and it will be replaced with omega. Then on the left side, we will have v equals, and on the right side, omega multiplied by r. So this is the relation between linear velocity and angular velocity. We can say that the linear velocity equals angular velocity multiplied by the radius. Now we will solve problems using the formulas discussed in this lesson. Many of these problems are problems from the handouts. Here we have the first one. A circle is cut into 6 pieces. The area of each piece is 57 square centimeters. What is the diameter of the circle? Let's start by drawing a circle. This circle has to be cut into 6 pieces. The area of each piece is 57 square centimeters. So what we have here is the area of a sector of a circle. Now recall the formula for the area of a sector, that is A equals 1/2 theta r squared. If in this formula we replace A and theta with numbers, then we can solve it and find the radius. Then once we know the radius, we can multiply it by 2 and find the diameter. So far we know that the area is 57 square centimeters. Now let's talk about the angle theta. Assuming that the circle is cut into 6 equal pieces, we can find the angle theta by dividing one full rotation by 6. If we would work with degrees, then 360 degrees divided by 6 would be 60 degrees. Then we could say that this angle has a measure of 60 degrees. However, in the formula that we will use, theta has to be in radians. And we know that 360 degrees is the same as 2 pi radians. Then we can find angle theta by dividing 2 pi by 6. If we reduce the fraction, we will get pi over 3 radians. So now in the formula to the right, we will replace A with 57 and theta with pi over 3. Then 57 equals 1 over 2 times pi over 3 times radius squared. On the left side we will bring down 57, and on the right side we will multiply the fractions 1/2 and pi over 3. 1 times pi is pi, and 2 times 3 is 6, multiplied by r squared. Now we have to solve for r squared. This means that we have to remove this fraction that is in front of r squared. We will do this by multiplying both sides of this equation by the reciprocal of pi over 6, which is 6 over pi. So we will multiply this side by 6 over pi and this side by 6 over pi. Once we do this, on the right side, pi and pi will cancel, and 6 will cancel, and we will have r squared alone. On the left side, 6 times 57 is 342 over pi, and on the right side we have r squared. To find r, we will take the square root of 342 over pi. But to find the diameter, we will multiply this quantity by 2. So we will have 2 times 342 over pi. Here we will use a calculator, and we will get that the diameter is approximately 20.9 centimeters. In the next example, a fan has the radius of 35 centimeters. What is the linear velocity when the fan is rotating at 6.7 revolutions per second? In this problem, r represents revolutions. So again, this r does not represent radians. Instead, it represents revolutions. If we would use radians, then we would write a complete word, radians, or we would just write r, a, d. But just r alone means revolutions. Now, to find the linear velocity, we will use the following formula. V, which is linear velocity, equals omega, which is angular velocity, multiplied by the radius. We are given the radius, and the radius is 35 centimeters. We are also given the angular velocity omega, and this is 6.7 revolutions per second. However, to be able to use this quantity in the formula, we need to convert revolutions per second into radians per second. So then, we will do this first. We know that 1 revolution is the same as 2 pi radians. Using this, we will convert the angular velocity from revolutions per second to radians per second. Omega equals 6.7 revolutions per second. And now, using this equality, we will form a unit fraction where the numerator will be 2 pi radians and the denominator will be 1 revolution. So then, we will multiply this quantity by 2 pi radians over 1 revolution. R and R will cancel, and the units left will be radians per second. We will multiply 6.7 by 2 pi, and that will give us 13.4 pi radians per second. So then, omega equals 13.4 pi radians per second. Now, to find the linear velocity, we will replace omega with 13.4 pi and r with 35. Then v equals 13.4 pi multiplied by 35. We will use a calculator and we will get that the linear velocity is approximately 1473.4 centimeters per second. In the next example, a sector of a circle has the arc of 450 meters and the angle of 81.5 degrees. What is the radius of the circle? We will start this problem by drawing a circle. Here we have a sector with the arc length of 450 meters and the angle of 81.5 degrees. We will find the radius of this circle. We know that the formula for the radius of a circle when we have the length of an arc and the angle is r equals s, which is the length of the arc, divided by theta, which is the angle. We also know that to be able to use this formula, this angle has to be in radians. However, the given angle is in degrees. Therefore, the first step will be to convert this angle from degrees to radians. So then, 81.5 degrees, we will multiply it by pi radians over 180 degrees. The degree symbols will cancel, and 81.5 multiplied by pi and divided by 180 will give us approximately 1.42 radians. Now, in the formula above, we will replace s with 450 and theta with 1.42. Then r equals 450 divided by 1.42, which is approximately 317 meters. And this represents the radius of this circle. In this example, a sector of a circle has the central angle of 140 degrees and the arc of 15.2 meters. What is the area of the sector? Let's start by drawing a circle. So here we have the circle. The length of the arc is 15.2 meters and the angle is 140 degrees. We have to find the area of this sector. We know that the formula for the area of a sector is A equals 1 over 2 theta r squared. To be able to find the area, we need to know the angle in radians and the radius of this circle. We are given angle theta, but this angle is in degrees, so we will start by converting 140 degrees to radians. So then, 140 degrees, we will multiply it by pi radians over 180 degrees. The symbols for degrees will cancel, and 140 multiplied by pi and divided by 180 will give us approximately 2.443 radians. Now, we know the measure of angle theta in radians, but we still have to find the radius. We know that the radius can be found by dividing the length of the arc by the angle theta, and theta has to be in radians. So then, the radius equals 15.2, which is the length of the arc, divided by the measure of the angle in radians, which is 2.443. Then the radius is approximately 6.222 meters. Once we know the measure of the angle in radians and the radius of this circle, we will replace these two quantities in the formula above and we will find the area. So then, the area of the sector equals 1/2 multiplied by, in place of theta we will write 2.443, and in place of r we will write 6.222 squared. With the help of a calculator, we will have that area of this sector equals approximately 47.29 square meters. This was the last problem of section 8.4, Applications of Radian Measure. Thank you.